So this is the end point. All we need to do is draw a dotted line perpendicular to the displacement axis, and then we shade the region between the graph, the displacement axis, and the dotted line. So this region we have to figure out the area for. So the area of this shaded region will give us the value of the work done. So now we can solve this question using the concept of area. Here we can see we have a graph. Y-axis is force, x-axis is displacement, and we have to figure out the work done by F in moving the toy through a distance of 4 centimeters. First of all, the value of force is not constant, which means the formula Fs cos theta we cannot even apply. So be very careful. This formula is only applicable if forces are constant, which it is not clearly in this case, as the force is gradually decreasing from 5 to 0. So Fs cos theta won't work. So what do we do? All we need to do is figure out the area under the graph. So in this case, if I shade the proper region, this entire region is what we need the area for. So how do we figure out the area? This shaded region is a triangle, and the area of the triangle is half base into height. So if you look at the base of this triangle, that is 4. But look at the unit on the axis. So we can write down the base as 4 multiplied by 10 to the power minus 2, because on the x-axis they have mentioned 10 to the power minus 2. And the height of this triangle is 5, as you can see here. So we multiply this by 5. And now if we simplify this, we will get the area as zero point 0.1. Hence, we can now write down the work done by this variable force will be equal to 0.1 joules, since joules is the unit of work. In this question, we have a 74-kilogram boy which is riding a 6-kilogram bicycle starting from rest. So initial speed is 0. The graph shows how the acceleration varies with distance. So on the x-axis, we have displacement or distance, and the y-axis is acceleration. And we are supposed to find the total work done by the boy. So how do we approach such questions? So we already know the formula. How do you find the work done when the forces are variable? We do area under the graph. So work done is equal to the area under the force displacement graph. Now the issue with the graph which is given to us in the question is y-axis is not force, it is acceleration. So we need to make some changes to this particular expression. So work done is area under the force displacement graph. Now the formula for force according to the Newton's second law, if you remember, F is equal to m into a. So if we replace F with ma in this expression, we will write down work is equal to area under ma in the bracket multiplied by s graph. Now, in most questions, the mass of the object is always constant. So we can take mass out of this expression. So this expression can be written as, see, we have taken m out. So work done will be equal to mass into area under the acceleration displacement graph. So this is the expression which we need for the question. So work done will be mass. So first we need to figure out the area under this acceleration displacement graph. That's step 1. And then we need to multiply that with m, where m will be the total mass. So going back to the question, let's see what is the total mass. So the boy is having mass of 74, but the bicycle is 6 kilogram. So the total mass will be the addition of it. So 74 plus 6 will give us 80 kilogram. And now all we need to do is figure out the area of this entire graph. Now the simplest way to find the area of this region is divide it in 3 parts. So we can see this particular region is a triangle. So let's try to figure out the area of this. So the base of this triangle is 5 and the height is 2.5. So let us write it down. So we'll write half into 10 into 2.5. So now if we simplify this, we will get 12.5 as the area. Similarly, the triangle on the right side, which I am shading currently, this will also be having the area of 12.5. But in the middle, we have a rectangle. Now the base of this rectangle is 10. So it is 20 minus 10. So this is equal to 10. And the height of this rectangle is 2.5. Hence we can write down the area of this rectangle, the middle rectangle will be 10 multiplied by 2.5, which is equal to 25. So what is the total area? So we have 2 triangles and 1 rectangle. So we'll write 12.5 plus 25 plus 12.5, which comes out as 50. So the area under the graph is 50. So now we can figure out the work done by multiplying this area with the total mass, which was 80. So 50 into 80 will be 4000 joules, which can be written as 4 kilojoules. Hence, option C is the answer to this question. Here we have been given a graph for a spring which is having the original length L naught. So this is the relaxed length when the spring is neither compressed nor stretched. So the original length is L naught. But when it is stretched to a length L by a variable force, the graph represents x-axis is the force, y-axis is your length of the spring. And we need to figure out the work done against the spring. Now, work done is always the area under the force displacement graph, but we need to remember the steps. Step one was to draw a dotted line towards the displacement axis. So if I consider the end point of the graph, you need to draw a dotted line, but perpendicular to the displacement axis. So this will be that dotted line. It needs to be perpendicular to the displacement axis. This is step one. Step two, we need to shade the region between the graph, the dotted line, and the displacement axis. So this entire region is equal to the work done, which is x. So the answer is the area marked x. A is the answer for this question.